that, explain to you what solar panels actually do to generate the electricity. Where does the electricity go?
Fortunately, Mr. Johnson, we're able to see exactly how much electricity our solar panels generate on a daily basis and over an extended period of time. So, Mr. Johnson here has a picture. I'm going to try to talk as loud as I can. A picture here of our website. Okay? Great kids. Scroll down, Mr. Johnson. And when we come down to the bottom, we have a section where it says quick links. Okay? The arrow is pointing to track the solar panel. When you click on track the solar panel, what's going to happen is it's going to take you to an outside website. Okay? And it looks like this. The company that has provided us the service is called Enlighten. Pretty cool name. At the top you see Fairview School District 72, and it says Skokie, Illinois. So, pretend today is 57 degrees. Okay? It's probably roughly about what it is outside. I haven't been outside, but 57 degrees. We have an overview of how much energy our solar panels are producing and generating into electricity. So the first box where it says power production. Okay? Our solar panels generate 46.7 watts of energy. Okay? Today, our solar panels have given us 2 kilowatt hours of energy. Past 7 days, 58 kilowatt hours. This month, 177.4 kilowatt hours. And the last number is the same because we haven't added up for a month yet. So over time, that number is going to get larger and larger and larger, and we're going to save a lot more electricity.
In fact, you actually see our solar panels down here and how much power they're generating at any given time. If you scroll down on this website a little more, give you some graphs. This is pretty cool stuff. You can see it starts off with a lifetime, past 12 months, past 8 weeks, past 4 weeks, past 7 days, and of course the past 24 hours. This graph shows us the last week, and you can see that each peak is our daytime energy, and each trough would be nighttime when there's no sun to power. Well, you can see that these guys, this is yesterday, and you can see there wasn't a whole lot of sun yesterday, and so we didn't make much electricity. But if we go back here, I think this is Thursday or Friday, you can see it's a perfect arc. This was a great day in Fairview for generating electricity.
So lots of sun, lots of energy.
You can also see here that since we installed the solar panels, which has only been about 3.5 weeks, or 4 weeks, we've created enough energy to power 538 light bulbs. I think it's unbelievable. And also the equivalent of 177 computers.
And as we continue to have solar panels for a longer period of time, those numbers are going to go up. So keep your eye on the website, and it's going to increase. On the bottom is the carbon offset. So at this point, we've saved 4 trees planted based on our offset and 16 gallons of gas. So solar panels are working.
That's exactly right. It's also important to remember that you've all used solar power before. You ever got a glass of ice water and left it in the sun for too long? What happens to it? It melts, right? So the ice melts and the water gets a little warmer. This isn't a great use for solar power, but you are using energy from the sun.
I know I have this question, Mr. Johnson, and many students might too. When I was little, I always looked up in the sky and thought the sun was so small. How do we get so much power from the sun?
Well, that's a great question, Mr. Lepaka. Let's take a look. I actually have a model here. Here we go. So, we're going to imagine that this is the sun. Now, this is only about 40 inches in diameter. It's not very big. The actual sun in real life, if we were there, would be more than 800,000 miles wide. So it's much bigger than this guy. That's okay.
So, based on how big the sun actually is, the volume of the sun is 1.3 approximately million times the volume of the Earth.
It's much bigger. In fact, even this comparison isn't accurate. If the sun was this big, the Earth would be much, much smaller. If we take a look at the next slide, you can see just how small the Earth would be. In fact, the Earth is so small compared to the sun that you could fit about 1.3 million Earths inside of the sun.
Right? Now let's say you wanted to travel from the Earth's distance to the sun. Okay? That's about 93 million miles from the Earth to the sun. It's pretty far. Okay? In equivalent, you would have to drive around the Earth in your car 3,700 times to get to the sun. So that's a long distance.
That's pretty far.
Yeah.
In fact, it's so far away that the light from the sun takes about 8 minutes to travel all the way from the sun, all the way through space to here on Earth. It's pretty incredible. If the sun was suddenly to explode, we wouldn't know about it for about 8 minutes. pretty amazing. So we're going to create our little model here. This sun is only about 40 inches in diameter, but if we were to create a real scale model, this is only approximate. If we create a real scale model here, our Earth would be about the size of a dime, right here.
So, me not being a science guy, Mr. Johnson, about this distance, right?
No, actually the sun would be much further away. If the sun was this size and Earth was this size, we're going to have to spread out a little bit. So,
all right, I'm going to go down the steps.
Okay.
All right, so right here, right where the fifth graders are.
Yeah, no, you're going to have to go a little further.
You kidding?
Yeah, keep going.
There you go. Right where these guys are?
Nope, yeah, keep going.
Right where the
Keep going.
all right, it's got to be here. This is about it, right? Right here?
No, further.
Oh, man, this guy. Here, Mr. Johnson, right here.
Keep going, please.
I'm tired. What about here?
Okay, that's about right.
Perfect.
Look at the sun. Pretty big. Now look at the Earth. Pretty small. This is roughly how far light travels from the sun. Remember, energy from the sun is transmitting in all directions, not just towards us, in all directions. But only that little bit of energy that's coming towards us is enough energy to power our little solar panels right here on Earth. And remember, it takes that light 8 minutes. If Mr. Lepaka could run at the speed of light, it would take him 8 minutes to get back here.
Which I can't do. That was a joke, laugh.
Alright, so we're going to take a look at some other uses of solar power.
So in our community and society, there are many ways we can use solar power. This is cardboard, right? Actually, it is a solar oven. What happens if you were out in the wild, in the woods, and needed to survive, you can put this on the ground with food inside, and the sun's power would create enough energy to cook your food. So, I open it up, I have my breakfast.
Take a little while. That's a solar oven. Another good use of energy is this little thing here. This is actually a solar-powered water heater. You can see the water in the top of this bottle here. Break it. It comes down this tube and into this little miniature greenhouse. The energy from the sun comes into this clear plastic and gets absorbed by black. We all know that black is a really great color for absorbing heat and gets trapped inside, heating up the water in the tube, which then goes back into here. This has been sitting under this light for about an hour now, and the water is actually pretty warm. Definitely works. Pretty cool.
So the next thing is that this imitates sort of how our solar panels are working. We have a little solar panel. Okay? Connected to it by a simple wire is a solar motor. Okay? So when the solar panel conserves light, what's going to happen is it's going to make the motor spin. So with our light source over here, obviously we don't have the sun, we're going to use this light right here. Once I put the solar panel underneath the light, the fan will spin, giving us electricity. So, can you see that in front? It's spinning. I'm just holding it wrong. I promise to work good. There we go.
Nice.
Okay? So, as we take it away, it is going to stop. Right?
And then you can turn that simple application into something a little more complicated. This is a solar-powered boat. A little solar panel here, connected to an electric motor, which is then connected to a fan. So if we put this under the sun, we're going to use a light. So we'll have this sun here to get some juice. We take this and actually put it inside of our if it wasn't so sunny outside, it wouldn't work. So let's do it one more time. This time we're not going to get quite as much sun. Maybe it's a cloudy day. We're going to get this much. You aren't going anywhere fast. But in the middle of the summer, when there's plenty of sun, you can crank it.
So, for my 8th graders, I know we talked about cell phones and how they've evolved over time. Right? Everyone has a cell phone. 3rd, 4th graders, I hope you have a cell phone. But if you do, okay, what is coming out next is the idea of solar-powered cell phones. So the next technology is instead of a battery powering your cell phone, it is going to be a small solar panel. So that's replacing the battery inside your phone by using the sun's energy to give us the ability to talk on a cell phone. Now, they're not very popular yet, but that doesn't mean that down the road, we're going to have solar-powered cell phones.
Indeed. Another application we use, and we heard talk from apps talking about this, is solar power in your home. Panels used to be really expensive. They are still pretty expensive, but they're coming down, which is good. Which means someday in the future, we might all have some solar panels helping us in our own home.
And another of the most common modes of transportation is the car. Okay? Now, today, many people, family, or your friends in your family might drive hybrid cars. Okay? This is taking it to the next level. What you see here is a car that has a solar panel on the top. The car doesn't look so bad. It's a regular car. But what it does is it conserves the energy from the sun and gives the car power. Makes sense. Okay? Now, many of you are probably thinking, well, that's like me thinking that cars are going to fly. Well, no. This is next year's model for the Toyota Prius. So the 2011 Toyota Prius. Now, that solar panel is not going to be on every car. It's one of those things that you have to pay in time to get it put on top, but it makes sense.
Very cool. And of course, the most advanced application for solar panels would be a calculator. I'm sure you've never seen this before. Of course, we've been using this technology for a number of years now, about 30 years. And I'm sure some of you in math, maybe science too, have always played the game with cover solar panels.
Yep. So, well, that about wraps it up for our presentation for the day. We hope you had a great time. We gave you a chance to learn about the opportunities of solar energy in the community, at our school, and we hope you have learned something from Mr. Johnson and myself.
Exactly. We actually have a very short video to show you before you go. Before that, we would like to thank a few people. Thank you guys for taking the time out of school. Thank you teachers for letting them come down. And thanks to administration for being so supportive throughout this whole thing. It's really good.
You're going to remember one thing from today.
Just one thing to remember.
Save energy.
Think green. Thank you very much.